Hello my dear students, welcome back to chemistry class. Today let us continue the lesson Chemical Effects of Electric Current. Let us revise what we have learned in the previous class. We have learned what are good conductors of electricity, poor conductors of electricity, checking the conductivity of a material using a conduction tester, checking whether a tester is working or not, testing whether a liquid allows electric current to pass through or not. So today we have to cover the topics tester based on magnetic effect of electric current, checking whether the liquids are good or poor conductors, and also classifying materials as good conductors and poor conductors instead of classifying as good conductors and insulators. So before starting today's topic, let us see which are the three effects of electric current. There are three effects of electric current. One is heating effect, another one magnetic effect, and one more chemical effect of electric current. So what is heating effect? Already we have seen in the previous class. In a conduction tester, if the liquid conduct electricity, the bulb glows. Why? Because when the current is passing through the wire, the filament of the bulb get heated up and the bulb glows. So here a part of electricity is converted to heat energy. That is a heating effect of electric current. Today we are going to learn the magnetic effect of electric current. Based on that, how we can make a tester. Then the next class we will learn what is chemical effect of electric current. So before starting today's topic, one more point we have to keep in mind. So this is a conduction tester. It contains a bulb, a battery and a few conducting wires. Using this, we can test whether a liquid conducts electricity or not. So here, instead of using the bulb, we can use an LED also. This LED glows even when a weak electric current flows through the circuit. We have seen in the previous class, sometimes even though current is passing through the circuit, the bulb does not glow. What is the reason? Because the current is very weak. But if you are using LED, even though a weak current passes through it, it glows. LED glows. You can see here there are two wires connected to an LED, attached to an LED. One LED is, these are called LEDs. One LED is slightly longer than the other. So while connecting the circuit, we should remember that the longer LED is always connected to the positive terminal of the battery and the shorter LED is always connected to the negative terminal of the battery. Now let us come to today's topic, magnetic effect of electric current. So you know this is a magnetic compass. You know magnetic compass always show north-south direction. It is also called mariner's compass because the mariners used to know the direction. Always it show the north direction. So when a magnetic compass is kept nearby a wire and the current is flowing through the wire, we can see the compass needle of the compass get deflected. You can see here. So when a compass is kept nearby a wire and the current is passing through that wire, we can see a deflection of the magnetic compass. What's the reason? This shows that electric current produces a magnetic effect. This is called magnetic effect of electric current. So we can use a magnetic compass instead torch bulb or LED in the circuit. What is the advantage? Even if the current is small, the deflection of the magnetic needle can be seen. So let us see, using this magnetic effect of electric current, how we can make a tester. So let us see how we can make it. tray from inside a discarded matchbox. This is a matchbox. From this we have taken the tray. Wrap an electric wire a few times around the tray. Here you can see around the tray we have wrapped a wire, electric wire. Place a small compass needle inside. Inside that we have kept a small compass needle. Now connect one free end of the wire to the terminal of a battery. Leave the other end free. Take another piece of wire and connect it to the other terminal of the battery. So what we have done here, we have taken a discarded matchbox, we have removed the tray from that, and we have wrapped an electric wire a few times around the tray. And one end of the wire is connected to the one terminal of the battery and the other end we left free. And one more piece of wire we have taken that is connected to the other terminal of the battery. And if you join the free ends of the two wires momentarily, we can see the compass needle deflects. What does it mean? Current passes through it. So when the current is passes through the wire, the compass needle deflects. Now our tester is ready. Now let us see how we can test the conductivity of liquid, whether a liquid is a poor conductor or a good conductor using this tester. For that we have taken lemon juice. Dip the ends of the tester into lemon juice. So we can see here the needle shows deflection. What does it mean? A deflection in the compass needle can be seen in the moment the free ends of the tester is dipped in lemon juice. It means that lemon juice conducts electricity. So it is a good conductor of electricity. Now take out the ends of the tester from the lemon juice. Dip them in water and then wipe them and dry. Now we can use this tester to test the conductivity of other liquids. For example, tap water, vegetable oil, milk, honey, etc. So each time what we have to see, we have to take the tester from the free ends of the tester from the liquid and we have to dip it in water and we have to wipe it. Then only we have to dip it in another liquid to test whether they are good conductors or poor conductors. So in each case, observe whether the magnetic needle shows deflection or not. Then we have to record our observation. So let us see. When the lemon juice is taken, we are dipping the tester, free ends of the tester in the lemon juice. We can see the compass needle shows deflection. That means it is a good conductor of electricity. If you are dipping the free ends of the tester in vinegar also, we can see a deflection in the compass needle. So it shows vinegar also a good conductor of electricity. Tap water also we can see the same effect. So it is also a good conductor of electricity. When we dip the free ends of the tester in vegetable oil, there is no deflection of the compass needle. What does it show? It shows that vegetable oil is a poor conductor of electricity. If you are dipping the free ends in a milk, also we can see the deflection. That means milk is a good conductor. In honey, we cannot see the deflection. That means honey is a poor conductor. Now, observe the circuit given in the figure. Current does not flow in the circuit if there is a gap between the two wires. You can see a gap between the two wires. And this magnetic needle doesn't show deflection. What does it mean? A current is not passing through the air. Does it indicate that air is a poor conductor of electricity? Definitely. It indicates that air is a poor conductor of electricity. Does air never conduct electricity? Let us see. But during lightning, an electric current passes through air. So what does it mean? Actually, under certain conditions, most materials can conduct. That's the reason we can use the terms. It is preferable to classify materials as good conductors and poor conductors instead of classifying as conductors and insulators. So we have learned today tester based on magnetic effect of electric current, and how to test the conductivity of liquids, whether they are good or poor conductors of electricity. And it is better to classify materials as good conductors and poor conductors instead of classifying as conductors and insulators. Hope you understood today's class. Thank you, children.